Hi, my name is Daniel Eriksson and I'm going to present to you my research topic. The topic is called Automatic Bucket Filling for Wheel Loaders using Machine Learning Techniques. Wheel loaders are very versatile machines which can do a lot of different tasks, and one of these tasks is to fill the bucket from a pile of material and then unload it somewhere else. The bucket filling process is very repetitive, so this makes it a good target for automation. It's also the most fuel-intensive task and requires the most experience from the operator. And depending on how skillful the operator is, the fuel consumption and the time to fill the bucket can vary considerably. The reason behind this is that the operator typically needs several years of experience before being able to perform an efficient bucket fill. However, this is challenging to automate because several factors are hard to predict and changes constantly. Examples can be the environment the wheel loader operates in and the material the wheel loader operates on. Depending on the material to be loaded, it usually takes a different strategy to fill the bucket in an optimal way. With all this considered, it's very easy to see that there is a need to find a general and automatic approach to the bucket filling task. By achieving this, it will be possible to save money, both in terms of time and fuel efficiency. It will also be a big step towards making a fully autonomous wheel loader. So how do we do this then? Well, the approach I'm going to pursue is based on machine learning techniques. This will include techniques and concepts such as imitation learning, to learn from examples, reinforcement learning, to learn by exploring, and transfer learning, to learn from similar domains and share knowledge between them. By combining these techniques, it might be possible to create a controller which is adaptable and general. It is also important to study how the bucket filling is done manually by expert operators, and what techniques they use for an optimal bucket fill. This serves the purpose of gathering training data for machine learning algorithms as well as a baseline result. In order to rapidly test the pros and cons of different machine learning techniques, I will first implement them in simulation and then on real hardware. However, research in this topic is not new, and there has been attempts to tackle this problem in several ways before. Another approach is to use classical control theory. A problem with this approach is that it's hard to find a robust controller which works in every scenario, and you often have to develop a new one for each of them. This takes a lot of time and effort. And a machine learning approach, on the other hand, can use a lot of data to find a controller for different scenarios without the need of handcrafted control algorithms. And that's all I have to say. And here you can find my contact info.